Okay, business algebra, let's tackle 3.2, functions and graphs. It's taking some of the functions you should have seen before in life and maybe have been a while, and how to graph functions in general. So we need to go over all the parent functions. F of x equals x. We saw that in 3.1. That's the diagonal line through the origin. Slope of 1. Generally speaking, all linears are functions regardless of what happens. They're even one-to-one functions, so we can maybe talk more about that later. F of x equals x squared is our general parabola. Going up on both sides. Most people have seen that as well. Those are the two people tend to be most familiar with. F of x equals x cubed. So the thing about x squared is when you square in a negative number, it becomes positive, which is why it has that shape where it's going up on the left. However, when you cube a negative number, it's still negative, and cubing generally makes it a little steeper than squaring. And instead of going up on both sides, it's still going down on the left side. Something like this. Now the square root of x looks a little bit like the x equals y squared. The only difference is it doesn't have both sides of that parabola. So the square root of x is something like this. It's like a half parabola going to the right, only the top half. So that would have been similar to what x equals y squared looks like, because if you squared, this is y equals square root of x, and you squared it, you'd get y squared equals x, but you get some extras there. And the only way to make this a function is to cut off the bottom half of the parabola. Cube root of x is like x cubed, but the inverse, which means it's kind of on its side. So instead of going way out and up and down, it's going way out left and right. If you're wondering where I'm getting the points from, here, 2 cubed, 2 times 2 times 2 is 8. Here, that means it's the opposite. The cube root of 8 is 2. And the last one, people tend to not remember, but when I remind them about it, they're like, oh yeah, I've seen that before, is absolute value, which looks like a V, because remember, all the values inside an absolute value are positive, so it doesn't do anything on the right side. It looks like f of x equals x at the top left, but it takes all negative numbers and it makes them positive, so it's also going up on the right as well. Now, you usually don't deal with a lot of these functions much. If it deals with these other ones, besides maybe x and x squared, it's usually in the form of the parent function more than anything else. But usually it sticks to linears and maybe occasionally quadratics. At least when we get to the piecewise functions. There may be a few others before then. So let's try graphing some things. Graph f of x equals 3 minus x. You can either move the parent function, but for some of these, I recommend, if you're not sure how to graph it, make a table and plot some points. So if you weren't sure, let's plug in some points. I plug in 0, 3 minus 0 is 3. I plug in 1, 3 minus 1 is 2, 2, 1. If I plug in 3, I get 0. For a line, this really gives us a good idea of what's happening. 0, 3, 1, 2, 2, 1, 3, 0. I think we have an idea of what's happening. It looks like we have a slope here. Draw the line through, you can make it keep going. And that's all. I recommend always plugging in points so you have an idea of where it goes. You can use the parent function though. Normally the square root of x plus 3, remember what the square root of x looks like this. So you have to ask yourself, what is that plus 3 actually doing? Normally I have the point 0, 0. But here, what do I plug in to get 0 under the square root? It's actually going to take a negative 3 to be plus 3. So instead of starting at 0, 0, my square root is starting at negative 3, 0. Now you can also plug in points again. X, Y, negative 3 gives me 0. What's another easy number to take the square root of? 1. So I can have negative 2 plus 3, the square root of 1. Another thing that's easy to take the square root of is 4, 1, 4, or even 9, 6, 9, because those are our perfect squares, so they're easy to take the square root of. Like, well, how does this work? Should be 1, 2, and 6, 3. What I'm doing is negative 2 plus 3 is 1, square root of 1 is 1. 1 plus 3 is 4, that's where I was getting that. The square root of 4 is 2. 6 plus 3 is 9, the square root of 9 is 3. So if we plot those points, negative 2, 1, 1, 2, 6, 3, it gives us that same shape from over here that we had with the other equations. Lastly, this f of x equals negative absolute value of x minus 1. So we know the absolute value looks like this. So a negative absolute value is going to make it upside down, but let's just check with points. Let's plug in 0. What's 0 minus 1? It's negative 1. But the absolute value would turn that into a positive 1, but there's still a negative on the outside, so we're still back to negative 1. So you have 0, negative 1. Let's plug in 1. 1 minus 1 is 0. The absolute value of 0 is 0. Negative 0 is still 0. Let's plug in 2. 2 minus 1 is 1. The absolute value of 1 is 1. But then there's a negative in front, so it becomes negative 1. 3 ends up giving us negative 2 when we plug it in. So we actually see that point where our absolute value turns around. It looks like it goes up to 1 before going back down again. And you can plug in more points if you're not sure. Now, how are these going to be helpful? Let's look on the next page. Graphing piecewise functions. So graphing piecewise functions is a little bit more difficult. We really need to use the different domains to our advantage. I generally give these steps. I would plot the domains, the boundary points. It's the domain transitions. So what those are going to be in here, it says I switch between my functions at 0, so I need to plot 0 in both functions, and do it with open circles. And we'll talk about that in a second. And you shade the right circle. And then you graph either left or right. So what do I mean? I mean plug in 0 first for both of these equations. It says when I plug in any number, I get negative 2, so that includes 0. Here it says if I plug in any number, I get 4. So I have the point 0, negative 2, and 0, 4. So I'm going to plot 0, negative 2 with an open circle, and 0, 4 with an open circle. Fill in the whichever one, shade the right circle, not the one on the right, but whichever one has the equal sign. So the equal sign is in the equation where we got negative 2, so I'm going to shade negative 2 circle to say that that's the one that my 0 is actually in. Now, it says graph to the left or the right. Less than means to the left, greater than means to the right. So that's, which one has the less than? Negative 2. So I'm going out to the left from negative 2 following this function. This is a constant function, which means it is a horizontal line to the left. And this is also a constant function at 4, and since it's a greater than, it's going out to the right. So this is what a piecewise function looks like. It behaves like one function, has a transition point, and then it behaves like another function. And we'll do more in the next video.